I, Parth Khare, and my friend Divyam Pant would feel honored to be your show host for the event Uday, Naya Bharat Ki Neev, presented by Anusandhan, the Physics Society of Motilal Nehru College.
Ladies and gentlemen, esteemed guests and fellow enthusiasts, it is a great honor and privilege as I introduce our distinguished chief guest for the day, Professor Dr. Rajmal Jain Kothari sir.
Sir, your contribution in the field of physics has really made us proud and inspired. Ladies and gentlemen, he is an internationally acclaimed scientist of Physical Research Laboratory in the Department of Space. He is one of the founder in Udaipur Solar Observatory. Also, he is project director of Solar X-ray Spectrometer. He is also has been honored with numerous achievements in life so far. Some includes Lifetime Achievement Awards, Fellow of Gujarat Science Academy, Fellowship from Royal Astronomical Society in United Kingdom back in 2014, and many more.
As the sun guides us all towards the path of a visual destiny, sir, I feel honored to request you to please come upon the stage and cast your rays among all of us. Let's give him a big round of applause.
वो चेयर दो कैमरे का एंगल
Okay, good morning. And Principal Sir, Sasimawats, all faculties, dear students. First of all, let me express my sincere thanks to all of you for giving me an opportunity to be amongst all of you over here. First time at Motilal Nehru College. What basically today I plan is to give you a flavor of the sun, what it is, how it works, and what kind of variability it represents to us as a function of time. I will not go into the too much detail of the physics or the science part, but I will definitely also tell you how the really engine works and it sustains the life on the earth in all components of the earth, what we call as a Panchabhut Mahatattva, 5 different important components of our environment. So everywhere the sun actually puts its signatures, and whatever we do, any kind of action, the energy for that, the energy comes from the sun. So basically what I plan is to tell you what is the motivation, why we study the sun. You may simply ask question, sun is very old now and it is better to study the stars or better to study the plasma physics or other things. But sun is only actually a laboratory for whether it is mathematics or plasma or electromagnetism. It is in fact a big cosmic laboratory. So I will little bit talk about that. I will talk about the sun I will talk about the explosions which are taking place on the sun, known as flares, coronal mass ejections, and how these big explosions actually influence our Earth system. Then I will little bit talk about the climate also. What are the various kinds of phenomena which are taking place on the Earth? And then I will take you a little bit to the journey of the missions which were conducted for the Sun, particularly by me and wherever I participated. I briefly also participated in Chandrayaan, Mangalayaan also, all those missions. But I will not be able to cover about all those missions. On the contrary, of course, but I will cover the first solar spaceborne experiment known as Solar X-ray Spectrometer SOX mission, of which I was PI, Principal Investigator. Particularly my aim is to motivate all of you and to give you some appraisal that in this life, because it is only one time life given by the God, and so we should not get afraid with any kinds of under any situation. We should accept the challenge, whatever the problems you face in life, but never get scared with all those things. Problems always come. But once you make your decision very strong, then you can solve the problem. Let me start with a very brief. We have 1 hour, right, only?
So you can extend till 15 minutes more.
Okay, so I will very briefly tell you that the Sun actually was born as a protostar under the compression of the very high dense gas particles, etc. And when this collapsing force, that is we call as gravitational force, and then finally could take a shape of protostar of that protonebula, and then slowly around 4.5 billions of years ago it started the phase to form the Sun. So whatever the Sun we see in the sky today, that it is almost 4.5 billion years old Sun. It is not today's Sun. And in fact, on the top of that, whatever the Sun we see today in the sky outside from your Motilal Nehru College, the Sun is almost a 1 lakh year old Sun. जो आज आप सूर्य देख रहे हैं, that whole light actually was generated inside the core almost 1 lakh to 1,50,000 years. So whatever the Sun we study on today is actually the old Sun which we are studying. Because the light which we gather here, that comes from the Sun only in 8 minutes and 32 seconds, but it was generated few thousands of years back inside the core. So finally the Sun actually has a cycle like other stars and galaxies. Basically, like following to other stars, Sun is also a middle class star. It's a yellow color star on the spectrum, G-type star. And finally, you see, it is half-life already has finished, and after another say 3.5 or 4 lakh billions of years, it will grow up. It will grow up because the hydrogen, which is the main fuel inside, slowly that fuel is getting washed out, and the whole Sun will become a helium star, and then finally that whole envelope will go slowly outside. It will become a red giant, and finally a white dwarf, and it will end its life over there. So if you ask me where the Sun actually exists in our own galaxy Milky Way, and whatever in the night you see that white belt from the terrace of your house, so if you are able to go outside of our Milky Way, then you will see our Milky Way of this kind of a serpent kind of a structure. This is the real structure of our own Milky Way galaxy. We are somewhere from the center of this Milky Way 30,000 light years away. Do you have that laser pointer? Does not matter. So if you see, this is the center of our Milky Way, the 30,000 light years from here to here, which the light takes 30,000 years to reach to the sun from this center. And this radius is almost 50,000 light years. So you can say that from to this end, almost 100,000 light years is the diameter of our Milky Way galaxy. This whole thing, the sun, actually at this position, that is 30,000 light years away, it takes the whole family, what we call as a solar system, the sun, planets, our Earth itself, and all the other planets and the comets, etc., they move around the sun. Rotation and revolution takes place, revolution around the sun. And the sun, with its whole family, goes around this, the whole Milky Way. The sun takes this whole kind of a position like this, and that is in almost 26.5 crore years, what we call in our Indian literature, Brahman Varsh, cosmic year. That it was known to our Indian astronomers almost few thousands of years back. So this is the sun actually looks in our Milky Way galaxy, and you can see the other constellations and zodiac belts, etc. So basically, if you see the sun at very old time, when it was born, even few lakhs of years back also, not even now, or not very old, just few lakhs of years back, then the sun was not visible like this. It was not visible. The sun was radiating in the short wavelength, that is in high intensity in the high frequency wavebands, just like X-rays, extreme ultraviolet, etc. And so the question of existing of life was not possible on this. So if I go as a function of the age in giga years, 1 giga means 10 to the power 9, then almost at 10 to the power 8 years to add the current time, you can see the flux, that is the emission in the different waveband. That the 1 nanometer means 10 angstrom, so 0.1 to 2 nanometer like this. So it is keep on increasing, and you can see that basically the sun was emitting mostly in the shorter wavelength and not in the longer wavelength. But as a function of time, finally, in order to give the evolution of life on the earth, slowly the whole thing started, and this is the now wavelength in this, and this is the age, of course. The other way around I have put up over here, and you can see that now it has started radiating almost in the visible, ultraviolet, visible, and even in the infrared. You can ask a very simple question, सूर्य से धूप तो आती है, लेकिन गर्मी क्यों आती है? Heat. The heat is because of infrared wave, and the light is because of the visible wave. So these two now started very much enormous, and so since last few millions of years, now we are getting the light, whatever the sun which we are observing as on today, it is visible now only millions of years. You can see in this table itself also a very interesting data that how this really sun has covered its journey. You see, almost in giga years. So back in time, if you go like this, then the luminosity was not as much as on today. If I consider the luminosity about 1 over here at 4.5 giga years, then it was very much less. And slowly now the luminosity keep on increased, and what we see is a relative reference, 1 luminosity. The radius itself was very small, and now even the effective temperature, whatever we have now, that is the temperature of the photosphere. We will come just now, and the photosphere temperature is about the 58 degree, 100 degree or something. It was less. It means the sun basically was radiating more and more in the high frequency, high energy wavebands, etc. And as a result, what happened? When it started, then the sun, you can see the almost 4.5 gigayears back, the whatever the diameter is, it was small, which I just now showed in that table. And currently on today, the sun is of this much size. Because of this whole process in last 4.5 billions of years, the 40% now currently the sun is brighter. It is almost 6% or so in the size longer, and it is hotter also. So currently if you ask what is the regime of the sun, what is its curriculum vitae, then you can see that the mass is almost 10 to the power 30 kilogram or something like that. The radius is almost 700,000 kilometers. Volume is almost of the 10 to the power 33 centimeter cube. Luminosity is this much, and age is almost this. How I can tell to a small young schoolboy that what are all these numbers reflect? Just consider that I have a balance in my hand, and in one pan I can put the sun, then on the other side I have to put the 33,000 earths. This much is heavier than the sun. The sun is so much heavy. Okay? If I consider just sun as a football, big, and if it is possible to drop inside the earth in that football, then almost how many earths will come inside? 33,000 or 10 to the power that volume, so that much number of, so 3 lakhs, more than 3 lakhs earths will come inside. If it is possible to put the earths on its diameter line only, just on the diameter, you can accommodate 109 earths on that. Mala hoti thi, ginne Bhagwan, it has 111 built, right? 108 is the only, but 3 are from physics point of view, error bar, the top. So 111, whenever it will cross, the sizes keep on increasing. I just showed you, right? In the next 4 billions of years, so it will become 111. At that time, there will be no life on the earth also, because the sun will explode at that time. Okay, so this is some kind of a reality of that, and I will just take you to the journey, give you brief what is really happening inside the sun. So this is our by remote sensing satellite, and then going back into the space. Can you listen this sound? Are you all able to see? Okay, so this is our green planet Earth, and the satellite is taking all of us in the space. What I have done in this is I have taken images from many different satellites and used over them. So this is the Earth, the blue oceans, green forest green, and our nearest guest is the moon, and moon goes around the Earth. You all know that in about 27.5 days. That is what we call as a lunar month. And this moon, when it comes in front of the sun, then you all know that the total solar eclipse takes place. So when the sun, moon and earth, then they all come in one line. But this is the real picture taken by the solar and heliospheric observatories, Prof satellite. And you can see the magnetic field lines. All the bright areas are actually in the coronal, but when we see on the photos where they are the black dark sunspots, you can see here the magnetic field lines connecting from different active regions, sunspot regions from north to south. And I would like to have your kind attention on what I want to say, that such a high temperature, the energy comes in a convection form. I would like to have your attention how the fluid actually boils on the surface of the sun. So this is some kind of a representation of convection also on that. The sun basically is like a hot ball. and at the core, almost 15 million degree K temperature is there, and as a result of this high temperature, the whole gas is actually nothing but the plasma, okay? And this plasma, very high temperature, high heat, dense, high pressure, high temperature, so naturally thermonuclear fusion reactions set up. And as a result of thermonuclear fusion reactions over here, what happens that the energy is coming out, that hydrogen is fused every 1 second, and then it gets converted into the helium. Finally, those photons which are released, that's very high energy photons, gamma rays photons, extreme ultraviolet photons, etc. And they collide with each other or the matter over there. And during every collision, energy is lost and it comes to the lower energy, lower energy. So until it comes finally a journey as a photon, that such portion is known as the radiative zone. And after once the energy is finished as a photon, then whatever the heat is generated by those photons, that heat is then thrown outside. Actually, it is through the fluid bubbles, what we call as a convection. The energy is transported only by the three mechanisms: conduction, convection, and radiation. So this radiation is the one mechanism, then convection, and finally it comes as a photons, the visible photons, to all of in the form of the E equal to hd. Then so above that, in this whole structure, you will see that what I showed, the convection, those bubbles, they are here. Then the dark markings which you see, they are the sunspots, which I am going to describe you very soon. And then in sunspots are very high magnetic field, so they connect the magnetic field lines with each other from north to south, and then this energy is stored up, and whenever there is a disturbance in the magnetic field topology, then that p square over 8 pi, that is magnetic field energy, and the another is the plasma, that is kinetic energy, or you can say the NKT, our gas pressure or whatever, the thermal energy. So there is some kind of a balance, but whenever that balance is broken up and the magnetic field energy is thrown outside explosively, immensely, that is nothing but the flares and coronal mass ejections, etc. So basically the question comes that how this sun actually shines. So you have every actually the 700 millions of tons hydrogen actually participate, and every 1 second in that reaction, and that it gets converted into the almost you can say that 695 millions of tons and the 5 million tons every second energy is released in the form of this light and the neutrinos, etc. So all these things happen every second, and you can imagine as a function of time, the sun is losing hydrogen, and then in the very beginning I showed the topology, that whole model, how the sun will lose its energy, how it will lose the hydrogen, and finally it will get converted into the helium, and then finally it will become a red giant, etc. Surprisingly, what happens is very important on the sun, that the luminosity as we come outside as a function of the from the core distance, that the luminosity is increasing, and this pressure, this is keep on decreasing from the core to the photosphere, that is one. Then density is decreasing, temperature is also decreasing. Please underline. I would like to have, please remember this figure. Luminosity is increasing and it remains very high on the photosphere. That is what the sun we see outside in the sky. Pressure, temperature, and density, they all are parameters are coming down. But surprisingly, that is from the photosphere now here, as we go outer and outer in the atmosphere, that is from photosphere to chromosphere, transition region, and in the corona, all the other parameters are still being reduced, coming down, but temperature is all of a sudden going up. This is a big question till now. What is the mechanism that hits up the chromosphere and corona, how it makes different from the photosphere to this outer atmospheres, chromosphere, transition region and corona. This is still big mystery, although we are trying to solve this mystery, but I strongly believe whoever will solve this mystery, why the temperature shoots from almost 5,800 to 10,000 and 10,000 degree to 1 million and 5 million degree, he will get the Nobel Prize. And I believe that you young people, you are there for the future of India. You may be able to solve this question. So currently, whatever the two mechanisms which are coming to solve this mystery, one is the magnetohydrodynamic waves, MSD waves, which are actually being set up inside that almost near the photosphere, and they come and they transport the energy to the chromosphere and corona. This is the one mechanism which is being proposed. The second mechanism which is being proposed in that in the chromosphere, upper chromosphere and in the corona, a continuous small nano flares which are taking place. Continuously they are occurring inside the corona, and these nano flares actually produce also the high energy particles along with the hard X-rays, etc. And so they also release their energy continuously, and as a consequence, the corona is being heated up to the temperature of 5 million K or so. So let us see that this, I showed another the feature, the sunspots. I told you that about the sunspots which are visible, and this small, you can see on the sun, this is almost of the 1,400,000 kilometers. In this one active region, you can see so many number of sunspots are there, and each even a small sunspot is the size of the Earth. How much? Size of the Earth. And when you see still a small region of the sunspot, you can see that convection, what we call as a granulation. And this is the kind of work even you BSc and MSc students also can do, taking an image of say some 2 to 3 hours from the satellite, and you can re-register the images, and you can derive the 5-minute oscillations which all the time sun is revealing. 3 minutes of oscillations the chromosphere is doing. So this kind of a some kind of a practical work you can do. Even you can do from a small telescope sitting here, even in your Motilal Nehru College over here, and you can study the proper motion of the sunspots, etc. So whatever the very small, tiny sunspots, we call them as pores, but the innermost, darkest area is known as the umbra, and those going outside like this, in the form of a spiral rays, they are known as the penumbra. So you can just understand this. And these sunspots, when the Schwabe studied on for a longer time scale, he found that these sunspots basically are the 11-year sunspot cycle. They reach to the number density maximum to the higher side after every 11 years, or they go down to the minimum after every 11 years or so. So my first talk, actually the first task in my lifetime when I was 24 years old, after doing my MSc, when I was selected by the Vikram Sarabhai, when I was at BSc. When I did MSc, he already passed it. So, but he wrote a letter that this boy is selected and allowed him to do PhD, PRL, etc., etc. And I was asked that, okay, you are from Udaipur, so you established a solar observatory inside the Fateh Sagar lake, middle of the lake, and this is the more recent view of Udaipur Solar Observatory. Big telescopes are there, big magnetographs are there, etc. But when I started long back in 1975, then we made some kind of a spar, big, and then on that a telescope over there of the 10-inch diameter, 25 centimeter. And the first time we made a filter, of hydrogen line filter. You know that the hydrogen atom, Balmer line. You know Balmer line, H alpha? Yes. So I made a Balmer line, H alpha, that filter, optical filter by these Polaroids and all that. And then, so from that, actually, I started my PhD work, seeing the flares in that H-alpha line and many other features very nicely, etc. So this now, if you go on that, now new instrumentation is there. You may like to visit and take round over there. And now the question comes actually basically that how this magnetic field, sunspots, which are being observed everywhere from the ground stations all over the globe and from the satellite, but why these sunspots are being generated? So I will just give you a very simple cartoon. Okay, मेरी आवाज आ रही है आपको सब?
Yes, sir.
And can you see this rubber band?
Yes, sir.
Everybody can see?
Yes, sir.
Oh, wonderful. So just see, consider this as a sun. Consider this as a sun. You can turn on the light. So, and just see what I am doing at the center. This is the north pole of the sun. This is south pole of the sun. Okay, and this is the equator. And now I am pulling the equator a little faster to go around. That is rotation of the sun, and it has completed one rotation. It has completed one rotation at the equator. But as a result of this one rotation, what happened? There are two nodes. One node is in the north, other is in the south. Okay, everybody can see.
Yes, sir.
Right? Please apply physics. Okay? And now I am pulling further. Second round. Second round completed, and now there are two nodes in the north, two nodes in the south.
Yes.
Everybody can see?
Yes, sir.
And let us go for just for demonstration third round. What did you observe? The nodes, three nodes up and three nodes down, but the nodes are moving toward the equator. This is important.
Yes.
Nodes, all that nodes are moving toward the equator. Not going up. They all are coming toward the equator. It means the sun as a plasma body, it is not a solid body. It does not reveal a solid body rotation. Rather, it has a differential rotation. That is, the rotation of the sun at the equator is faster relative to the higher latitudes in north as well as in south. So the sun basically, at every time of rotation, the poloidal magnetic field, that is north to south, it is torture. It is torture. Okay? And once these nodes are what? The magnetic field lines nodes. And when they are actually accumulated at one place, so what we call them magnetic field strength per unit area is known as flux. Right? This flux. So once the flux is very, very strong, then you know also flux cannot remain, if it is so strong, connected with the main poloidal field line. So it will get disconnected or separated out. This separated out is nothing but in physics language we call that as a toroidal. Poloidal and toroidal. So toroidal magnetic fields are nothing but they are the sunspots. Okay? So this is what really happens in reality, and you can see in this how it really happens. So you can see that the sun, basically it is all the field lines, they are moving, but at the equator you can see that they are faster, and finally what happens? It all becomes chaos and they get disrupted. So how this poloidal magnetic field is being converted into the toroidal, and there it happens. Whether you see in different wavelengths, even X-ray or UV, as a function of time you can see these sunspots. But there will be a time when there will be no sunspot, that is known as the sunspot minimum year. There will be a time that there will be a very high sunspot numbers will be, and that is known as the sunspot maximum year. So maximum to maximum, it is almost about 10 to 12 years. Average, it is known as the 11-year sunspot cycle. So you can see that the sunspot cycles are distributed, and we have been observing since last more than 250 years. Now what happened that we were aware only about this 11-year sunspot cycle. My one student who is now associate professor, Nipa Bhatt, and she analyzed during her PhD that whole sunspot cycle and various other climatic conditions on the earth, and we found that the 80 years period and 200 years period of sunspot is basically the earth's climate period, and it is keep on changing over there. But recently when we studied that the whole ground surface magnetic field of the sun since 1995 or 98, it was almost very good, it was stable, but now it is all of a sudden, it is slowly going down. Now whether it is observational mistake or interpretation mistake or it is reality, still we have to wait for another 2-3 cycles, another 50 years or so. But if it is true, then it is a mystery because the earth will lose its temperature. Earth will lose its temperature, its anomaly will be there, and then we can expect something wrong is likely to happen on the earth also. So there are many, you can say, the sun is basic source and it can give always the many surprises. So it is not only new, but you can see here in the history, the last 400 years, there were many long sunspot minimum periods. So you can ask very simple question that on one side we say that 11 years minimum time is there, but why such long time? So the Maunder minimum was almost for more than 100 years or so, and then such minimum were like that. And during the minimum on the earth, the ice was frozen and lots of climatic, anomalies were there. So this is definitely that the sunspot actually plays a key role in controlling our weather and climate conditions. You can see here a very simple, the two times when this whole Europe was frozen during the Maunder minimum time and even in the 1910 also. So basically the sun actually plays through its energy source, photons, this climatic conditions. Now the people ask and believe in the here, oh, there is a global warming, like that. So whether it is really global warming by just this 0.5 degree, how much currently? About? You all know about, right? Global warming?
Yes, sir.
How much? 0.3 to 0.5 degree, and you can see here that the whole this much difference is just only in last 40-50 years, and that is because of the carbon dioxide emission. So there are the world scientists are divided into two. The one group that the climate is an emergency. The other group believes that climate change is a natural phenomena, it is not an emergency. Because the first group says that the global warming is there, but the second group says that the sun is also a major source, and you can see with the length of the sunspot cycle, the temperature, that global temperature is also changing over there. So it depends on the length of the sunspot cycle. So somehow, but the first group, that the climate is an emergency and they want to make it some kind of a big over, including the IPCC. They say that, by the end of the 21st century, it will become 1 degree, 2 degree, it will become hot and all that thing. The second group says that, no, the computers have done mistake, your calculation, your software program has done mistake, and how it is possible when out of 38, 36 big supercomputers say that it is all wrong. So there is still, we are not in conclusive format. So the first group asks whether you don't believe that is there any perfect proof of global warming. To the second group, that is, they say that the climate change is not an emergency. And you can see that from the Minakumari time, when almost in the last, the clothes were of this much size. In the current modern time, you know that we have come to this nanotechnology. So, they say that this may be the global warming, but this is not true. What is the truth is not because of that, but because of the Malkonovich cycle. You must have heard about the Malcolmovic cycle that the Earth various kinds of motions. Earth has around the sun the one important the revolution, and that is keep on changing as eccentricity, that major axis versus minor axis, and that is after every 1 lakh year it changes the whole temperature on the Earth. There is a precession also of the north-south axis, and then there is a tilt, that 23.5 degrees, etc. So all these have long-term cycles of starting from 10,000 years to almost 1 lakh year and so. So what reality it is like that? Yes, that what we did, we brought the sediment from the Antarctica, which is not contaminated, not polluted at all. Okay, from there, everything, the whole sediment from inside, and it was, analyzed at various institutes all over the globe, including our PRL also. And you can see a function of the time, that in thousands of years, and you can see the blue color is the temperature, that is how much it is actually anomaly, changing the temperature from the normal average temperature. So after every 1 lakh year, you can see, after every 1 lakh year, the temperature was almost very low, and that is what we call as a last glacier maximum. So it was almost -8 degree, and so the whole Earth, after every 1 lakh year, the whole Earth remains frozen with the ice, and ice to what extent? Up to the 10-story building or something like that. So only the very small creatures, small lives who can still tolerate, and they go inside the Earth and they remain survive. Rest of the all people like us die. So what happens that it remains so for so many thousands of years, and then the carbon dioxide which is there, it just gets exploded through the earthquake, volcanoes, etc. And once again the temperature goes on the Earth up. And we all are not very old. Rather, we all are only 25,000 years old on this Earth. You know that many extinctions were there, and the last extinction was of the dinosaurs. Okay, 65 million years. So you can see that, and you can divide this. This is all dust, etc. So whenever the temperature is down, and then the temperature again is taken over by the carbon dioxide. So on one side, the carbon dioxide, we say that it may kill, but the carbon dioxide is a boon to give the life. That is the real greenhouse gas on the Earth also. So this may be, but if you compare with the sunspot cycles, etc., on the shorter time scale, whatever I told to you just now through the Vostok, that ice core, it is thousands of year time scale. But on 11-year time scale, you can see that the sea surface level is keep on actually changing with the 11-year sunspot cycle. So it is the sea level is going up, going down, going up, going down along with this. So the sun actually puts its signature in the hydrosphere also. The sun puts its signature in all atmospheres. You can see the hurricanes in the atmosphere. They are inversely connected. So whenever sunspots are larger, the hurricanes are smaller in number, density is less. And whenever the sunspots are smaller, then the hurricanes are larger. You can see even in the plants also. The photosynthesis process, so all the trees, you can take a very old tree. Okay, you can take here even in your Motilal Nehru College, you can do this experiment, your biology, botany students, etc. You can cut the tree root, and you can see that 11-year sunspot cycle rings 1, 2, 3, 4, 5, 6, 7. In fact, in USA there is a tree ring research institute. Okay, and all the thick rings, it means heavy rains were there. All the thin rains means the rains were very feeble, of very low density. So by this, the whole plant ecology is based on the whatever the photosynthesis process is actually takes place based on the radiation received from the sun. So almost all, everything, and this actually told this information from the Trading Research Institute gave a new light that the rains are not uniform. Sometimes the rains are in particular sunspot cycle, they are very, very heavy. Sometimes it is very of the low intensity. So what happens? Then we found that actually the sun, the whole its poles, the whole poles of the sun, that is, this is north and this is south. So on one 11-year cycle, this is suppose the north and south, it changes in the next. This becomes south and this becomes north. This is one 11-year sunspot cycle. But in the next another 11-year sunspot cycle, again this will go north. So whenever the same homogeneous 22-year cycle, that is what we call it a magnetic cycle, comes, rains will be very, very heavy rains. And the next time, rains will be very low of the magnitude. So this is what happens, and I think another 20 minutes, okay? So you can see similarly, what we know the earthquakes and volcanoes, they are actually coming from the beneath of the earth, that is through the tectonic plates, right? Now, if they are from the tectonic plates, then why they follow the earthquakes only during the sunspot minimum time, not at the sunspot maximum? So this was in last 20 years, this was a big issue, big question that when sunspots are less, magnetic field is weaker, then who will take care? And inside the earth, it will something else. So it was found that whenever the sunspots are of low intensity, low in number, at that time galactic cosmic rays are always very, very high. GCR flux is very strong. Whenever the sunspots are very high, then the GCR automatically, because of the strong magnetic field, they are absorbed. It means during the sunspot minimum time, please, this is a big issue, and your students can undertake this, at least a statistical survey and research that at the time of the sunspot, when they are weak, why this tectonic plates, generally this is through the three mechanisms. You must be knowing that when they come closer or when they move, so the energy is released. So whether eddy currents are actually taking place, they are playing the key role, and if the eddy currents, then how they will enter inside. All there are many physics issues which are actually we have to address in this decade, how these things happen, whether it is not only earthquake but also volcanoes, also same during the sunspot minimum time. Okay, then this also took place at that time scale of tens of years, but in tens of seconds to few hours, what is happening and why it is the earth is disturbed, and that is because of the explosions. You can see that how much, and what we call as a coronal mass ejections. These are continuous phenomena many times when the large number of sunspots are there, the sun is actually flaring and exploding the energy outside. So this is the one kind of faster energy release, and it is of trillions of orders of magnitude, and you can see that when such kind of energy is released on the sun, then how the earth, what is that mechanism? The earth is disturbed. You can see that when the explosion takes place from the sun, the shoo, and then this whole plasma, charged particles, load is coming all the way from the sun to the earth. Earth is here, earth's magnetic field connected, and this compresses, splits up, breaks up the magnetic field lines from the sun side, and they get reconnected on the night side, and they produce the aurora, what we call northern lights and southern lights, etc. This is, and as well as what we call as geomagnetic storms, and in the atmosphere, the ionospheric storms, etc. So all these kinds of things happen, what that is covered under the subject space weather. So basically what happens, why this solar flares or coronal mass ejections take place? The whole thing, that this kind of magnetic lines of force, not only one but the millions and millions, and they are already connected. And nearby, if another magnetic field is generated over there, then this is compressed old topology, and then the breakup, that is what misconnection takes place in the magnetic field line. And when it cannot remain for a longer time, so at the top energy release is there. This is the magnetic field process is known as the magnetic field reconnection in the plasma. So the B square over 8 pi which was split up, then again it reconnects, and whatever the energy outside, they come inside, and the charged particles are accelerated to very high energy, okay, half mv square kinetic energy, and they travel all the way down, and they produce flare in the soft X-rays, in the corona, then the microwave emission in the corona, in the chromosphere, hard X-rays, gamma rays, etc. And all the way sometimes, even it is visible in the photosphere, that is known as white light flare or something. Okay, so Yoko also has discovered the same thing and many other mechanisms. In order to understand the various physics questions, physics mechanisms, what are the mechanisms responsible for the production of these flares, coronal mass ejection, etc. So dear friends, I was given a wonderful opportunity by Dr. Abdul Kalam to design and develop when the ISRO became strong enough. Okay, now we can take the new scientific experiments we conducted from the space. And 1997-98, when we were ready, our horse PSLV was ready to launch, and then we were doing also with the GSLV, the cryogenic technology, etc. And then I was invited from Jaipur Solar Observatory to Physical Research Laboratory, and then I started to develop a program that what we can do. You all must be knowing, ISRO never does anything as a repetition. Okay? ISRO always does something new. We never follow. We never become follower this time. So I was very clear cut, given a signal that we should do something new. Okay? And so we thought that what we can do, so then the first space-bound solar astronomy experiment, it was designed. So what was new in this? This was very important, that why we thought of this experiment. I would like to tell you that the model of the sun, the x-axis here is the photon energy, y-axis is the flux, and if you see from 1 kiloelectron volt to 100 kiloelectron volt, or even you can go up to 1000 kiloelectron volt, or here on this left side 0.1 kiloelectron volt. But the sun is composed, as I told, that of all various kinds of elements excited, changed their abundance and characteristics as a function of their temperature, etc. And so what we proposed that up to here, it was already up to 4 keV, everything was known, and the sun is always very hot. I told corona is of 5 million degree K, always hot, right? So all these elements one can easily observe. But what we found that once the sun is quiet, this in the corona, iron and nickel lines, they were not detected. Even they were not known also that there is a possibility of existing of iron and nickel in the corona. Theoretically, we proposed that these two lines should be observed when there is a flare. Why flare? Because once the flare is there, the temperature will reach to the almost of the order of 9 million K to 20 million K, or even much more. Once this temperature is there, then the iron and nickel lines should pop up. They should pop up, and we should be able to observe. The question then came by the reviewer or big scientists like Dr. Kasturi Rangan, all big, and they told that how you will observe this. It is very difficult. I proposed, I will come just now, but the question technically that how you will resolve, iron is at 6.7 keV. Please underline, at 6.7 keV, and nickel at 7.8 keV, 7.9 the difference is hardly about 1 kilo electron volt, and how you will resolve that this is the iron, this is the big question. Theoretically बोलने में बहुत अच्छा लगता है हाँ, लेकिन how instrument will do, and so that was the big question. So finally we proposed that in addition to this, what we will do, that during the solar flare, that is this pre-flare is this much, okay, during the flare, that is this red line, thermal flare, it should be there. But we propose that all the observations of previous observed flares, that strong flares, there is a super hot component. There is a 40 million K, 50 million K component, of course not observed by them, but it should be there. Then there is another mechanism, which is what we call as a non-thermal. You know that the particles, they follow the acceleration directly, half mv square, then v is very close to the c, velocity of light, then they go directly and hit the plasma. So that is not thermal, they are non-thermal, that is through the kinetics. So this is the power that follows the power law. So this blue line, I gave some codes you can read over here for the different kinds of temperature conditions, etc. So this was model, but at least one person was there, although he was an engineer, and he proposed his neighbor, Dr. A.P.J. Abdul Kalam, and he told, अच्छा कह रहा है तो मानो तो सही, क्या प्रॉब्लम है, कुछ करके दिखाएगा, but he has come with the new idea, and then we proposed this solar X-ray spectrometer, and this was the instrument basically. And for this, the whole world, there was no heritage. Nobody had used any time in the space the silicon diode, the pin diode, and cadmium zinc telluride detectors. These are semiconductor diodes detectors. So what I proposed, and that is small, is the silicon, very tiny, almost 3.4 millimeter dia, 5 millimeter dia, cadmium zinc telluride, collimators are there, etc., etc. We designed everything we were about to purchase, because India never manufactured silicon and cadmium zinc telluride detector. हम लोग तो बनाते कुछ बनाते ही नहीं, सब बाहर से खरीदते. So, but at that time, unfortunately, so 1998, what happened? You know that Atal Bihari Vajpayee was Prime Minister. Boom! Nuclear explosion, Pokhran 2 was there, and we all, whole India came under sanctions. And so there was a ban on ISRO, atomic energy, everywhere. We cannot buy anything from anywhere in the world market. Right? You all may be aware about that. आप छोटे young लोग हैं वो तो नहीं पता होगा, बहुत से तो शायद पैदा भी नहीं होंगे, है ना? So this was reality, and so we full ISRO came under sanctions, and the satellite was, that is GSAT-2. It was about to be launched in 2003, and this thing happened in 1998, 99. Then, fortunately, I should say fortunately, Dr. Abdul Kalam, he was not at that time president, he was a defense secretary, and he was given by PRL ISRO the senior scientist award, and he landed to the PRL Ahemdabad, and my director, at least, he was in favor of me. In those days, you see 4 crore rupees का budget, अभी तो शायद 50 crore या 100 crore के बराबर का होगा, and everything was almost, you can say, ताला लगा दो लैब के ऊपर, something. This was kind of situation. You see, I was under so much highly under tense. But director told that why don't you talk to Dr. Abdul Kalam and Dr. Kasturi Rangan. Dr. Kalam was there, and you all will be surprised why I am sharing this story to motivate you. इतना बड़ा आदमी, और वो जो ऑडिटोरियम है, ऑडिटोरियम का नीचे जो कारपेट लगा हुआ था, चेयर्स हैं और 2 चेयर्स के बीच में जो गैलरी है कारपेट, उस पर लेके मुझे बैठ. Okay, you tell Rajmal what is the problem, and I briefly described him the status of this purchase of this detectors. That unless detectors are there, we cannot go ahead, sir, and the whole experiment will be stopped. My career will be finished. this whole, I have done whole design, everything, how automatically things will work, etc. And then he told, how it matters? So these are his words. It does not matter. You develop detectors here, sensor. If they are not giving, then you develop the detectors here at physical research laboratory. From where I will bring crystals, and India has not done anything, and we will start to do even here. As of today, suppose it will take 10 years. No, don't worry. Satellite chala jayega. So, satellite nahi jayega. I am there. Don't worry. He called Dr. Kasturi, and everything was well arranged. You give him more money, he will develop. My director was also shocked. Detectors development in India, and we have never done. But this is what I wish to say. Then I also from inside, yes, this is opportunity, another opportunity. Before the satellite, let me develop the sensors here in India and get the control for India over the globe. And then this was a big opportunity. We started to develop detectors, semiconductors of this space heritage in India, and you all will be surprised. All will should take a note. अगर एक बार चैलेंज आपने ले लिया, चैलेंज लेना ही चाहिए लाइफ में. 3 साल में ही हमने डिटेक्टर 50 इंजीनियर और सब लोग लग गए, एंड 3 साल बिफोर 2003 तो पूरा इंस्ट्रूमेंट बना के रेडी करके और टेस्ट करके I wish to say that semiconductor, the silicon, it was taking the images at X-ray spectroscopy in 4 to 25 keV, cadmium zinc telluride 4 to 56 keV, because we wanted to see the high resolution that lines, okay, and the resolution was almost 0.7 keV, so that we can resolve those lines very clearly, explicitly clear, and the automatic whole instrument was always seen at the center of the sun. That is, the sun was always at the center of the sensor detectors. अगर आपका एक एक्सीडेंट होता है, डॉक्टर बोलता है फोटो पाड़ो एक्सरे का, and he will take decision after maybe 20 minutes, 30 minutes or so. Can you believe? बेटा आप लोग विश्वास करेंगे 100 मिलीसेकंड में 256 100 मिलीसेकंड में 256 ऑब्जर्वेशन this instrument was taken. 256. All automatic. Okay, nothing. I mean that whole everything and the size. First time it was miniature. This is the size of the whole instrument, and you can see. I'm sorry, it took some time to tell you the story. This is the integration over the satellite. रात के 2-3 बजे तुम मुझे कहा सो जाओ थोड़ी देर, and this instrument was, and this is the zero gravity test over there, and finally you can see that this the launch for the GSAT-2 was done.
Ignite exactly at the count of 0.
So on 8 March 2003, and this was the first precise and perfect launching of the geosynchronous orbit by the cryogenic technology. So this was the launch, and you can see the parallelly the observations which were taken in synchronous to the south of the sunspot, the explanations covered. So when these big explosions, we finally could see in the socks the smallest size of the flare. You can see on the left of this as a function of time, the intensity with different colors actually have different energy. We have 256 different energy. The big flares are also there. And once the big flares were there or small flares, the main interest, that iron and nickel line, the first time in the world we observed, and the astronomical telegram was sent to the NASA and all over the world. And as a result of this, Dr. Abdul Kalam and Professor U.R. Rao nominated my name for the Okay, so we came to another in between. As I told that I was involved in Chandrayaan, Mangalyaan and Chandrayaan 2 also, and now the Aditya L1 has been launched, and in Aditya on this L1 when I say means the 5 Lagrangian points are there. These Lagrangian points means the Earth is here, okay, and this moon is going around the Earth, and between the Sun and Earth, that is the distance 150 million kilometers, that is 15 crore kilometers, and at this 1.5 million kilometers away from the Earth, the L1, the Lagrangian point is there. What do I mean by Lagrangian point? Means the gravitational force between the Sun and Earth is balanced over there, and once this is balanced, then the satellite will go in some kind of orbit where you can manage to see the Sun all the time, that is 24 hours visibility is there, and similar kind of the 5 points are there, L1, L2, L3, L4 and L5. You can see that on the other side of the Sun, that is on the back side, from considering this Earth, the Sun and the L3, there is the line over there, and what you can put a satellite at L3 also, and you can see in advance what is happening on the back side of the Sun, and you can predict what is going to happen, what that is in the next 14-15 days. The L4 and L5 are for different purpose, L2 is for stellar kind of work, etc. So these different Lagrangian points are actually being used to explore the different kind of the physics, science, etc. So this, our Aditya, it is already launched now, you know that, and there are 7 experiments on this Aditya. You can see that the very first time the visible emission line coronagraph is there. It was basically till now we were observing above the corona by say some 1 solar radii or some other. The first time this visible emission line coronagraph will see less than in 1 solar radii. Then there is the ultraviolet emitting spectroscopy is there. Then solar low energy X-ray spectrometer is there, of which I am also expert. But this time I thought I will do different experiment. High energy orbiting X-ray, that is high energy hard X-ray. What I did this time is a solar wind particle experiment, plasma experiment, because what we think that the Sun is emitting continuously the plasma all the time, 24 hours, okay, and of various energies. So electrons basically and ions, they are being released from the Sun, and small energy, that particles, what we call the solar wind. So solar wind study, because it plays a key role in the influence on the Earth's climate condition, weather conditions, etc. On the other hand, the high energy charged particles of the order of 10 keV to 100 MeV, etc. And that physics also your students can participate in that. So that instrument was very, very important, and that instrument here made, and I was involved, and the Papa was from the, that is plasma analyzer, that is from our DSSC space physics. So almost these 7 experiments are there. They all are under testing, and I have a report that all the instruments are working very well. Only at the last 5 minutes, I would like to warn all of you. What is reality? What we see, global warming or this warming, etc. But if you see, this is from the Greenland, the real data, that blue line, and on the fitting modeled by this green line. And if you see, after this whole Mahabharata, when this Indus civilization was completely destroyed, right? the actual temperature came down, but as a function of time, 2000 साल BC के पहले के 2000 साल BC के बाद के, this is the data of 4000 years. I just want to give you a philosophical view only, that how the physics actually plays a role. Physics is the mother. You should all have pride that physics is the mother of all disciplines. All sciences are derived from the laws of nature, and laws of nature means physics. Okay, so you can see that the temperature goes up, down, goes up, down, goes up, down. Even modern assume that global warming, but it is going down. It's going down. कोई बात करता ही नहीं है ग्लोबल चिलिंग आने वाला है, सब ग्लोबल वार्मिंग बात कर रहे हैं, बट नोबडी टॉक्स के मरने का टाइम आ रहा है, वो तो कोई बात ही नहीं करता है ना. सो द अदर ग्रुप के क्लाइमेट चेंज इज नॉट एन इमरजेंसी, पहले कार्बन डाइऑक्साइड पे कंट्रोल करो, दैट इज मोर इम्पोर्टेंट. सो दिस CO2 emission is more important, and we all should remember that I have written some philosophical names also, even including my God also name is there. But you all know that there was a dark age also on the just by the onset of this BC, after BC and then medieval period, and little ice age was there also. उसको तो सब भुला रहे थे, है ना? But industrial people, they do whatever they want, but this is what the reality, and this is what going to happen. Okay, dear friends. मैं सिर्फ ये लास्ट 2 स्लाइड जो है कुछ ऐसी बात करना चाहता था. आई वुड लाइक टू, क्योंकि ये स्लाइड जो दिखाने जा रहा हूँ वो शायद आपको फिर ना देखने मिले, कभी भी नहीं देखने मिले. मुझे नहीं मालूम मैं फिर कभी आपके सामने आ पाऊंगा या नहीं आ पाऊंगा. इट ऑल इन द हैंड्स ऑफ सीमा. ओके, बट दिस इज अनदर वंडरफुल अपॉर्चुनिटी विच आई गॉट बिकॉज ऑफ अब्दुल कलाम. यू सी, when I was developing that instrument, that is the SOX mission, first solar mission, and in those days there was a period in 2001, 2002, there was a total solar eclipse visibly, and that total solar eclipse, which generally it is of hardly 30 seconds to 1 minute or something like that, but that was the time when the total solar eclipse was visible for more than 2 minutes. 2 minutes. So, सभी देश, all countries, they geared up what we should do, and so I was also invited by ISRO and Department of Ocean Development, DOD, जो समुद्र का, so Antarctica and all that. So, मैंने कहा सब में आइडिया तो दे दूंगा, कुछ नया कर सकते हैं, लेकिन मैं खुद जाऊँ और करूँ, इट मे नॉट बी पॉसिबल बिकॉज माई दिस एंड माई अदर Chandrayaan also and all the missions. Okay, you design and finally it was reviewed. So, what new thing you will do? I told we will take a very small telescope, not a big telescope, but what we are going to see. मैंने कहा सर आपको पता है कोहिनूर का हीरा देखा है आपने? आप पैसे किसने देखा? किसने देखा? अच्छा ये बता सकते हैं कोहिनूर किसके पास था भारत में? बेटा आपको पता है कोहिनूर किसके पास था? ऋतिक रोशन. Yes, please give a big hand for this. राजा रणजीत सिंह के पास में था. तो स्टोरी ये थी कि उसके टाइम पे जो गोल्ड स्मिथ सुना होता है वो बेचारा आंध्र प्रदेश से, अभी तो नए नाम है हम लोग, हरियाणा पंजाब ये सब पुरानी बात बता रहा. तो जब वो वहाँ से आ रहा था वापस पंजाब की ओर, जिसको आप पंजाब बोलते हैं, और बीच में आंध्र प्रदेश पड़ता है, और आंध्र प्रदेश में आपको पता तंबाकू का, टोबैको का फार्मिंग बहुत होता है. टोबैको का जो पत्ता होता है इट इज़ वेरी बिग, इस साइड से बड़ा बड़ा होता है ना. और उसमें इफ यू सी तो ऐसे छेद नहीं होता, उसमें स्लिट बनती. क्या बनती? स्लिट बोलते हैं ना अपन, स्लिट बनती. अब वो उसको देखा, उसने अचानक दिन के टाइम पे सूर्य गायब हो रहा है, तो उसको लगा कि हाँ ग्रहण बोलते थे. तो वो बेचारा डर गया, वो छुप गया. किसके पीछे छुपा? उस तंबाकू के पत्तों के पीछे. और लेकिन उसकी था जो पता नहीं कब होगा, तो वो स्लिट में से धीरे धीरे देखता था, कभी छुप जाता, कभी देखता, कभी छुप जाता. So जब when total solar eclipse was there, at that time you all will be surprised, a magnificent view he saw. वो खुद अपनी आंखों पर विश्वास नहीं कर, भगवान ऐसा भी कुछ दृश्य दिखा सकता है, ऐसा भी होता है. So whatever he saw, he described to the king, Raja Ranjit Singh. Raja Ranjit Singh gave him a big crystal of the gemstone diamond, and he told, जो तेने देखा वो बना के फैब्रिकेट करके दिखा. उसको तो नहीं पता था कि मैं बना दूंगा, इसलिए मेरे हाथ काट दिए. लेकिन he developed, and so what I am going to show, what I told to the at that time Prime Minister and all, this will be a unique opportunity. This will be a unique opportunity because it is a longer duration total solar eclipse, and perhaps we may be able to see this cohesive scene again, once again, after 200 of years. So before the experiment, before the totality starts, just white card sheet रखी हुई थी, जिससे दिखे कि हाँ shadow bands बनती हैं because of the change in the pressure in the atmosphere. So you will be able to see that what do I mean by this trapezium, the Kohinoor star, and you should enjoy this video all. You can see shadow bands.
उधर देखिए, समझे, उधर देखिए, मैं ये पूरा लेता हूँ.
Shadow bands दिख रही हैं, bands, dark bands on the white.
आप देखो डायमंड नहीं देखो,
This is Antarctica.
beautiful famous. My God, my God, oh my God, fantastic.
This is Professor SP Bagari. No, it's okay.
अरे क्या ग्लो हो रहा है भाई? दो आ गया, वो डायमंड नहीं आ रहा है, prominence आ रहा है.
Let's see here. Thank you very much. So in conclusion, I do not to say that the sun is a variable. It gives, you see, over the thousands of years to the tens of seconds changes. It sustains life on the earth, etc. It gives many surprises. It controls the climate and even the future of our world. Thank you very much, dear friends, for
हम स्ट्रीम बंद कर दें, बंद कर दें.
अभी नॉर्मल पिक्चर्स भी अब कैसे